So one of the tricky things with recursion is recognizing when it might be a good idea to use. There are a couple of patterns or things that you might see that tend to work well as recursive solutions. First of all, anything that has to do with a file system. So something like this here where we've got different folders and you want to write a script that will look in every folder for something or create a file in every folder. Whatever it is, if you are traversing, navigating a bunch of nested directories, it's much easier to use recursion compared to trying to do it iteratively. Another example, if you're ever working with fractals, who knows, maybe you will, great example of recursion. You have some outer pattern that is being repeated again over and over and over. Parsing, so parsing mathematical expressions, this is just one example. Imagine that you were given a string that looked like this, and your job was to actually calculate it, actually output a number, do the math. And no, you can't just cheat and use eval or pass it into some function that will calculate it for you. You need to actually write the function that will parse all of this. This is another area where we have nested data. So as we encounter something, 1 times something, well, that's easy enough. Oh, but this is actually not a number. We need to calculate what this returns or what this evaluates to. So you could recursively calculate this and then recursively calculate this. You do have to pay attention to order. This is a very interesting problem. If you're looking for something to really test yourself on, this is a great exercise to try, but it's not easy. Anything with nested data, so the DOM, for example, or just HTML, anytime you have nested anything, and we just worked with nested arrays of numbers with other arrays, and recursion worked well and helped us there. Anytime you're working with HTML, if you're trying to traverse it, you're trying to find something, if you wanted to try and recreate query selector all, get element by ID, those would be much easier to write recursively rather than iteratively. We will see more examples of recursion in this course as we start to get into other data structures. So for now, if you feel shaky on it, totally understandable. It's a topic that is tricky. It's kind of a different way of thinking about code. If you ever get stuck, put a debugger, put a breakpoint in your code and walk through the call stack. Hover over values, see what's going on. So those are some common situations or types of data that lend themselves to recursion. But as we've already discussed, you can write anything recursively. If you can write it iteratively, you can write it recursively and vice versa.